Hello students, welcome. In this session, we'll be seeing pointers and functions. In particular, we'll see call by value and call by reference. Learning objective is to understand pointers and functions, and in particular, call by value and call by reference. Session outcomes: you should be able to understand how to use pointers and functions, call by value and call by reference. Prerequisites: should have learned first 3 units. Let's get into pointers and functions. Usually, the arguments are passed from a calling function to a called function using one of these two methods. First one is passing the values of arguments. If you pass the values, then it's called by call by value. If you pass the addresses of the arguments to the called function, then it's called by call by reference. So from calling function to called function, you would be passing the either values. If you pass values, it's called as call by values. If you pass address, then it's called by reference. Let's see call by value. This is a common type of invocation of functions wherein the calling function passes the value as the arguments. What actually happens inside this is that when a function is called by the value, the compiler creates the temporary storage area where the copies of the actual values are stored. There are two values, right? There is a calling function. That calling function will call a called function. So the parameters that are there in the calling function is called as actual parameters, whereas the parameters that are there in the called function are called as formal parameters. Here, when you are trying to pass the values from the calling function to called function, in other words, from actual parameters to formal parameters, then you are going to create the copies of the actual parameters and store them in a temporary storage area. Then the called function picks up the values from those temporary storage area, then assigns it to a formal parameters. So there is a copy that actual parameters have value and they are stored in some temporary location, and from there it is taking and putting it to formal parameters. So there are two different variables, each having the same value because it is copied from the temporary area, and within the temporary area the actual parameters are values are copied. Okay. Thus, if you make any changes to the formal parameters, those are not affecting the actual parameters here because it's a copy, it's a carbon copy. Original is there, but you're copying it to another variable. We're making a carbon copy. If you change anything in the carbon copy, the original is not touched and it's not changed. Similarly, if you change anything in the formal parameters, the values are not affecting the actual parameters. Hope it is clear. Let's see an example here. In this, we're declaring a int a and b. There is a function. We're initializing the a and b to 20 and 30 respectively, and you are printing the value of a and b before calling a function, right? So now it will print 20 and 30. But after calling the function, what you're doing is you are passing the value 20 and 30. These a and b are actual parameters, but these x and y are formal parameters. The value is copied into a temporary storage. From temporary storage, the values are picked up and they are copied into a formal parameters x and y. and whatever the changes that you do to x and y should not be affect this a and b. A and b would be original and it's remain intact. Thus here if I do x plus x assigning to x, y plus y assigned to y, then this x is 20, y is 30. Once it comes here, 20 plus 20 is 40, x is assigned to 40, and now here y is 30 plus 30, 60, the 60 is assigned to y. Then 40 and 60 respectively for x and y. Right. After this, I am coming here and I am trying to print the actual parameters only, a and b. A and b, after calling the function, what will be the value of a and b? A and b would be same 20, 30. The x and y are changed here, but not the a and b. Thus, a and b will remain intact. Now let us see the call by reference. Whenever we pass the address from the calling function to the called function, then it is called as a call by reference. Whenever a function call is made, if we pass the address of a variable to a function, the parameters receiving the address should be pointers. The process of calling a function using pointers to pass the address of a variable is known as call by reference. So here, to receive the address, right? To receive the address, the called function should be having a pointers, because pointers can only hold the address. Thus, the calling function is passing an address. The called function should be initializing with the pointers to hold the address it is passed. Right? So, in this case, what's happening is that since you're passing the address itself, any changes that you make to the value through the addresses to be the same value. Thus, the changes that you make in the calling function would also get reflected in the called function. Let's see this. It will be more clear through this program. Here int a and b is there, a comma b. There's a typo here. It's not a dot b, it's a comma b. And you have function a and b before calling a function. There will be 20 and 30. But here, while you call the function, you are passing the address of a and b. Right? You are not passing just the values. You are passing the address where the 20 is stored. Passing the address where 30 is stored. Let's say A is stored at 1000 and this B is stored at 2000. Or for simplicity, since it's 20, let's say A is stored at 20,000, B is stored at 30,000. And then I'm just printing after this calling function. And here, once this function is called, it will come here. This is passing a address. A is passing address. This is 20,000. B is 30,000. So it will come here. This is because it's a pointer, because it has to hold the address. And then star of x would give you the value that is there in the 20,000 address. That is 20. 20 plus 20, you are assigning to once again, making it a 20, 20, 40, and you are assigning to that the value where the x having the address 20,000. Within that address, go there and put the value 40. Similarly for y is 30,000. If you say star of y, in 30,000 what is there? 30 is there. 30 plus 30, 60, and 60 is assigned to the same star of y. Then return 0, it's just coming back, and after that, here I am saying a comma b. What is a comma b? A is having ampersand of a is 20,000, ampersand of b is 30,000. If it goes there inside and guesses the value, it has been already changed in the called function, because called function also went through the address and changed the value, and here also the same address is there and you are accessing the values there. Thus you will get a changed values. Thus if you call by reference, any changes that you made in the called function, those changes would get reflected in the calling function as well. Thus here is A and B would print 2030, and after this function call, since you are adding it, it will show A is 40, B is 60 after calling the function. Hope this is clear. Just a recap. The call by value method of passing arguments to the function copies the actual values of an argument into the formal parameters of the function. Whereas call by reference method of passing arguments to a function copies the address of argument into a formal parameters. Since you are passing the address, any changes that you make through address would get reflected in the calling function. Right? And these are the references that you can refer. Thank you.